Welcome back to another video on evaluating functions. Today we are doing inverse functions, and before I actually define what this is, I just want you to see how it kind of all works out. So I'm going to use a basic linear equation. I've got y equals 1/2 x minus 3, and I'm graphing it, so I start at -3, and then I go up 1 over 2, and I'm going to, in this case, write out the points for this linear equation, and I'm going to end up having two equations. So what I'm going to do is I'm going to name this one f of x so that I can differentiate, and I'm going to write out the points that I've plotted here on this graph. We're just going to use 3 of them. So 0, -3, 2, -2, and 4, -1. All right. So I've decided to do another table, like I said. I'm going to call it g of x. And I have put the new points for this new equation. Now, notice where I got the points. What I've done is I've just switched the x's and the y's. And so for my points, I have -3, 0, -2, 2, and -1, 4, just switching the points from here to here. Okay, now I have decided, since I have a table here that's in blue, I'm going to go ahead and make this line, which is this table, in blue. That's why you see it's such a scribble there. Okay, and so then what I'm going to do is this line's going to be in green. So I've made this line, and I just plotted the points. Okay, I have not created the equation yet. That's okay. I just want you to see how this all works out. Now, answer this question. What's the difference between these two lines, or what do you see between the two lines? Okay, notice that I've created a dotted line down through the middle. This dotted line is actually the equation y equals x. If you said that the two lines were a reflection of each other across the line y equals x, you're going to be right. An inverse, okay, is where I switch the points x and y, and if I switch the points x and y, I will get a reflection of this line over to this line. I will get a reflection of these two lines across the line y equals x, which is right here in the middle, this red dotted line. Okay, now how do I figure out what this equation is? Well, I could write the equation. If I went up here and said, okay, this line crosses at 6, and I'm going up 2 over 1, I would have y equals 2x plus 6. But let's see how we can discover the equation algebraically from our original equation here. So I am looking to make g of x, which is y, equals 2x plus 6. Okay? Using the fact that I switched the x's and the y's here, let's do the same thing with the original equation. Let's take the y and the x and switch them. So y became x and x became y. Now I'm actually going to solve for y. So notice that I took the 3, added it over. Now I have x plus 3 equals 1/2 y. If I multiply by 2 to get rid of the 1/2, then I will have y equals 2x plus 6. And that's how you find the inverse of an equation. These two are inverses of each other. Okay? All right, so we're going to talk about this one more time. You've got f to the -1. Okay? That states that I want the inverse of f, or f of x. Okay? There's another way to write this. Think about this. What is 2 to the -1? I just told you that f to the -1 means inverse of f of x. But if I write 2 to the -1, you already know how to evaluate that. We've been talking about it. So what is 2 to the -1? 1/2. Wouldn't you agree that 2 over 1, the reciprocal of 2 over 1 is 1/2? So the inverse of something is really just thinking of it as a reciprocal of it. Okay? So let's look at this again. We have f of x equals 3x minus 5, and we want the inverse of this function. So I'm going to go ahead and take f of x, and I'm going to change it to y. And the rule is you switch the x's and the y's. So I'm going to change y to x. I'm going to change the x to y. Did you notice that I have not changed the 3 and I have not changed the 5? Okay, so when you do this, please remember, because the problems might get a little bit more difficult. If you switch, you only switch the x and the y. Don't change any numbers. Even if you saw a 1/2 or a fraction or a squared or a cubed, anything in there, don't change the numbers, just switch the x and the y. Now I'm going to solve for y. So I add the 5 over, and I have the 3, so I've got to divide by 3. So I'm going to have y equals 1/3 x plus 5/3. That is the inverse of f of x equals 3x minus 5. Okay, last thing that we're looking at here is a table that is f of x. The x values are 1, 5, and 6, and the y values are 3, 8, and 11. All right, think about this. If I ask you for the inverse of a table, the inverse of a table means that I want to switch the values. So in this case, if I switch these values, it would be 3, 1, 8, 5, 11, 6. Okay, so if I ask you for the inverse of 8, that's going to become, 8 is going to become my x, and my y is going to become my 5 if I switch the values. So 8, 5 means that the answer is going to be 5. All right, these are just some different ways of looking at inverse functions. We will have some basic ones for practice, and then as we start doing more of them, they will become more complex with some x squareds and things like that. But for right now, focus on these inverse functions, and then we will have some more videos on them.